Alright, so today we are looking at graphing logarithms. We'll also do some finding the inverse of a logarithm, which as we've mentioned before is an exponential, and evaluating, just a brief refresher on evaluating. So first off, we're going to graph the log base 5 of x. And the way I say that is the log base 5, 5 is the little number, of x. And I put parentheses there just so you really know what we are taking the logarithm of. So as usual, we will make a table. Let's start with finding the log of 5. We'll do 5, 25, 125, and 625. And you'll see in a second why I chose those numbers. So log base 5 of 5 means 5 to what power gives me 5? Well, 5 to the first power is 5. So that gives me the point 5, 1 on my graph. Then I'm going to find log base 5 of 25. So I can ask 5 to what power gives me 25? Well, 5 squared gives me 25. And you can see why I've now picked these terms, because these are the numbers that's 5 to a specific integer power, which makes it very nice to graph. So I find 25, and my answer is 25, 2 for that point. Then I can find log base 5 of 125. Well, 5 to the third power is 125. So then I can plot 125, 3. Then I'll do 625 log base 5. And I get 4 because 5 to the fourth power gives me 625. So that's points way over here. So you can see that it's really leveling off, kind of like our square root graphs, but even more intensely than our square root graphs. Okay, what we didn't do is take care of anything down here. So what if I had 1/5 fraction? So log base 5 of 1/5 is actually -1, because 5 to the -1 power is 1 over 5 to the first power, which is 1/5. So 1/5 is about 0.2. That means really right here, it goes down here. I'm not going to make you, but really what you need to know is it's going to approach 0. So for my honors people, as x approaches 0, y approaches -infinity, because as we get smaller and smaller fractions, that means I'm raising 5 to a larger and larger negative number. So when I see your graphs, you don't have to go down forever. I do want to see at least that you know that the logarithmic function goes negative, though, when we have a fraction. Now you'll notice we don't go into the negative x realm because 5 to no power will ever be a negative number. Okay. Let's look at number 2. This is your second type of problem you will see. Find the inverse of y equals log base 3 of x. Well, there's 2 ways to do this. I'll show you the way to find the inverse, but the easiest way is just going to be to know the pattern between the inverse and the exponential. To find an inverse, that means you just switch x and y. So I replaced y with x, I replaced x with y. Now I want to solve for y. So what do? I raise 3. I bring the 3 over here, as you guys have been doing in your work. And then that takes the logarithm away. So that means 3 to the x is y. So that is our inverse function. Now it's nice to know that that is y, but you can also just follow a pattern that if your function is y equals log base 3 of x, the inverse is just 3 to the x equals y. Right, those are inverse functions. They undo one another. So last type, and you've seen this before, what is the value of log base 3 of 81? Really what you're saying is 3 raised to what power is 81? So you can either type that in a calculator if you have it, or you can ask yourself, okay, 3 raised to what power gives me 81? Well, 3 times 3 is 9, times 3 is 27, times 3 is 81. So it's 3 to the fourth power. So that means the value of log base 3 of 81 is 4. All right, best of luck with what you've been doing in your workbook.